So we'll get started. Thanks for coming, everyone. Hope you're having a great Unreal Fest so far. My name's Matt, and I'm here to talk about supporting mods in UGC in your Unreal Engine game. So a little bit about me, just before we start. I have a very long background in history in modding. I started modding when I was a teenager, working on Half-Life 2 mods, released Age of Chivalry on Steam, was very tightly involved in the Half-Life 2 modding community, as well as a contributor to ModDB. So modding is really what built my passion for the video game industry and kind of got me into this sort of work. I started using Unreal Engine back in the UDK days, so back in 2012 or something like that, so very old experienced Unreal Engine developer. As part of Pub Games, we ship Primal Carnage on PC and PlayStation 4, including Steam Workshop and mod support on the PC version. I'm now head of engineering at Mod.io, and if you're not familiar, Mod.io is a solution for delivery, moderation, and management of user-generated content. It's functional on PC, consoles, and mobile. Now, this talk isn't a sales pitch for Mod.io, but we've helped dozens of customers ship over 150 titles with mod support, including plenty of large AAAs. So a lot of the content that I'm going to talk about here will draw from that experience and sort of some common pain points and challenges we've seen from customers that we've worked with. So just to sort of cover what we're going to talk about today, I'm going to start at some really high level. Why do you want to add mod support to your game, some justifications and reasons for it, some existing solutions that already exist inside of the Unreal ecosystem, and why I think we can do a little bit better than that. We'll talk about pack files, summarize a little bit how they work, why it's important to understand the IO store, and then we're going to go ahead and actually do a basic implementation of mods as DLC plugins, which will basically allow you to load that content and manage that content dynamically. We'll talk about ways you can structure your content to basically be mod capable, and then some final thoughts for things that I won't be able to cover to kind of help you along with your journey. I've chosen all these because they are all common things that we see studios have difficulty with, so you can consider this like an end-to-end roadmap to be able to add mod support to your game. There are some code-heavy sections, but it's all code that does come from an open source repository that Mod.io has shipped, so I'll provide a GitHub link at the very end there, and you'll be able to go and grab and have a look at that source code. And just one note, I'll use the words like mods and UGC interchangeably, but generally they mean the same thing, which is custom content created by an external content creator that your game can load and make playable. So I assume that everyone who's in here has some passion or reason for being interested in UGC. Some of you might have got into the industry through modding like me. You grew up on great games with great mod support, Half-Life, Unreal Tournament, those sort of games. You might already have a passionate creator community that you want to foster. You might just want to emulate the success of Fortnite or Roblox and kind of create that big, rich UGC experience. But obviously adding this support does take time, and often in business you need a justification to be able to do that. Mod.io commissioned some simple research into the impact that mods have on games that add support for it, if you need that information to kind of take back to your studio to justify it. So on average, games with UGC make more money. You can see that by year 5, games with mod support had a 23% advantage in revenue over those without mod support. And games with mod support have greater retention. By year 2, they had a 64% advantage in concurrent user count, and that was up to 90% by year 5. Generally, we don't see mods impacting DLC sales, if that's a concern. There are many games on Steam that have seen their DLC sales increase as a result from engagement in UGC. Part of that is some clever implementation of mod support, where they allow creators to use that DLC and then upsell that as part of the mod usage to get sort of better DLC sales. And just generally speaking, it is a good content funnel for your studio. We all know that creating content's expensive. There are plenty of talented creatives out there who want to be able to make content for your game, so you'll be able to get the benefit of a steady, engaging stream of content for your players. Just note this data actually comes from Steam Workshop. It doesn't come from Mod.io. And also consoles are still a huge, largely untapped market for mod support as well. We have seen a very large desire for this support, and we think there's a lot of opportunity to increase your revenue, increase your retention and get that exposure for creators if you're shipping on consoles. We've seen massive success in Baldur's Gate 3 recently that shipped mod support on consoles, really positivity for Witcher 3 announcement, both titles which Mod.io support, and players sort of really love that opportunity to play UGC on consoles. And ultimately, one point I'll come back to is players want to make content for your game. If you've made a game that's remotely popular and go on Nexus Mods, you'll probably see some mods there for it. So we think you should give those creators an official toolkit, integration and support, and reap the benefits that come from that. So let's talk about the existing solutions. There's 3 that I kind of want to touch on. The first one is simple UGC. This is a project and plugin that originated from Robo Recall, which was a commercial VR game that Epic shipped mod support for. There's UE for SS, which is a third-party community-driven injectable Lua C++ blueprint system that basically injects and sideloads binaries to add that mod support to your game. And then there's what I call the Just Hack It Together group of people, which basically use community tools to reverse engineer your content and then use the engine's pack loading, priority, and patching system to be able to get that content loaded in-game. So a couple of quick pros and cons for each of these. Simple UGC is a proven structure. If you're not familiar with how it works, it has what they call an actor replaceable component. You put that component onto an actor to indicate that it can be replaced by something that someone else has created. They create a mod, you create a mapping to say, I want this actor to replace this actor. On startup, it gets put into a UGC registry, and then anytime you spawn that class, you just look for any overrideable actor that's part of that. So it's kind of fairly easy to reason about. You have a lot of good control over exactly what can be replaced. It includes really good built-in mod templates and packaging tools that are very creator-friendly. You can make it work on consoles, but it doesn't work out of the box because it uses that engine startup loading behavior. On the cons, there's no UE5 support. You could upgrade it. It's not really that much friction. And that class swapping model, basically anytime you call spawn, you have to look up a class replacement for something, which is a lot of overhead, or you've got to modify the engine spawn method to do it. So it's potentially not really that scalable for a really rich kind of support. UE for SS is no lift for your studio because it's entirely community driven. It's very well tooled. There's heaps of open source tools for reverse engineering Unreal content, reverse engineering to get headers and those kind of things. Lua is very flexible. Developers are very familiar with it. But obviously it's all loaded with DLL injection. This can cause problems with antivirus, anti-cheat and those kind of things. And it also means it won't work on platforms other than PC. You can't just take UE for SS and integrate it into your game as a plugin to be able to get it to work across all platforms. And of course, because the community generates the mod kit, headers, etc., major updates to your game can break, and the community's got to go and redo that work to generate that content. Same again with the Just Hack It Together crew. It's no lift for the studio. Creators just use those community-driven tools to be able to reverse engineer content, but it's pretty limited, basically limited to asset replacements because it overrides content that's in pack files, which means it's also PC only and again relies on the engine's auto-driven behavior. So why would you want to build it yourself? Well, I think the pros, it can be more fully integrated into your game. Content can be managed in-game, it can be loaded and unloaded, and as a result, because you don't have to physically go and put files onto a file system, it'll work on consoles. And that's one of the big drivers at Mod.io is to open up that whole world for players and creators on consoles. And as I mentioned, players are probably going to mod your game anyway, so provide an official solution to get those benefits. The cons here, it does require a bit more development time and thought because there is some work you have to do to be able to make that content loadable, unloadable, and manageable. There are some requirements for the console platforms that can add some complexity around that. And generally, you're a little bit more limited in what can be moddable because you can't replace every single asset really easily. But these cons are the things that I want to try and kind of take out of your thinking today by talking about the ways we can do this and some of the patterns that will basically allow you to really easily ship that support. So I want to spend a few minutes just talking about pack files, a bit of a primer, because there's some online tutorials which tell you to do things like disable IO store, and there are various settings and those kind of things, which I think a lot of people don't fully understand. So let's just really quickly do a 101 on pack files. So pack files are Unreal's way of bundling content for a target platform. They're produced from the cooking process. And when you cook content, it's optimized for that specific target platform, which means that that pack file can't be loaded by another platform. This is a slight oversimplification for how pack files are loaded. There is a more complicated internal priority system, but loosely speaking, any pack file that ends with _p is a patch pack file that's prioritized for loading by the engine. And then basically the engine will start at the root packs folder. It'll iterate through all of the pack file chunks that are in there and then all the subfolders and then load all of that content loosely in the pack alphabetical order. And the reason that means that those Just Hack It Together crew can override content is because anything that's looked at later patches over an earlier looked at asset. So as an example, if pack chunk 0 and pack chunk 1 both have an asset at game/character.u asset, the one in pack chunk 1 takes priority. So just to talk about the differences between pack and IO store. So if you're cooking without IO store, which was the way in Unreal 4, you just get a single pack file per chunk. This is loaded by something called the event-driven loader, otherwise known as the EDL, which essentially is just a simplified file system that you can iterate through really easily and reference files inside of. It is a legacy pathway. It's no longer updated in the engine. It's essentially maintained to facilitate migration for titles coming from Unreal Engine 4. The default since Unreal Engine 5 is the IO store. You might have heard a few other people talking about the Zen loader or Zen storage, and Zen is basically the entire system that the IO store uses for a lot of its content dispatching. It produces three files per chunk: a pack file, which is for loose infrequently accessed files like asset registry and localization; a UCAS file, a content addressable store, which holds the actual cooked content; and a TOC file, table of contents, which is basically a lookup for the content within the corresponding CAS file. You can't actually mix these either, so if your game is cooked with IO store, you can't load a pack file that's cooked with non-IO store if that's what your modders are doing. So it's kind of important to understand these. You should always be shipping with IO store turned on. It is more performant, it's the default pathway, it's maintained and updated, optimized for streaming and all those new systems like Zen streaming, Zen storage, etc. So all this talk is going to assume that you're using IO store in your game. So let's go through the actual steps to implement mods as DLC plugins. So the very first thing you need to do is prepare your release. So whenever you release your game, or you're doing an internal test build, have to make sure you create a named release of your game as a reference point. So releases are a baseline, which Unreal uses to produce deltas of content that's being cooked as part of your base game, and then anything that's being added to your game, such as new content, DLC, extra plugins, or something like that. If you've only ever released on PC, you might not be familiar with the concept of creating this base release and then patches on top of that, because on Epic Game Store or Steam, those tools can basically just take two fully cooked game pack files, do the delta for you, and only produce those differences and allow players to download those. But if you're shipping on like mobile or console, then you actually do need to produce these base releases, produce those patch files, and provide those to the console holder to download patches for. Mods as plugins basically use that same system where they create essentially a customized pack file, which is used from that base release and reference from that. You do need to create a release for every platform you intend to support. So to do that, this is not the 5.6 project launcher. 5.6 is a new project launcher, but the buttons will be the same. When you open the project launcher and go to package your game, there's a little drop down here, which is release DLC packaging settings. You want to check the box that says create a release, and then you want to name the release. Now this name can be anything, it's just a string. You could call it UGC release 10 or whatever, but I'd recommend that you just line it up with the versioning system that your game's going to use. If you're using the command line or build graph, you simply pass the -create release version parameter into that. This entire command line here is like loosely kind of the structure that we use internally in our test project from our internal build graph scripts for producing those releases. Once you do that, the output that you'll see a new releases folder inside of the game. That release name that you gave, in this case 1.0, will be a subfolder, and under that is a list of every single platform that you've created a release for. Inside of that is a copy of the asset registry.bin, which has been produced for that version. That's the same one that will ship with that release of the game. Inside metadata is like a development asset registry.bin for development purposes as well. So then create a mod as a plugin. So just create a standard regular plugin. Again, if you want to follow like the simple UGC robo recall method, you could just give your creators some tools inside their own editor to be able to do this. One thing I want to call out is to use U-plugin fields to help identify content that is UGC. So if you're not familiar, the U-plugin is just a JSON file, and there's a field in there called category. Set that to something like UGC or some unique identifier for your game that identifies that it is actually a piece of UGC. That'll become important later when we actually go to look up and load this plugin. So you can see here, I've got my plugin here. It's Chicken Blade. We've got a primary data asset as the first asset there. We've got meshes, textures, all that sort of stuff. And then on the far right-hand side, we've got this UGC metadata asset, which is an additional data asset that we sort of produce to drive some functionality when you actually load that plugin and pack file, and I'll get back to that a little bit later. So recalling back to that base release, we want to build your mod as a DLC plugin based on that release version. So in that same drop down there, in that release DLC patching settings, instead of populating those top two, you want to say the release version it's based on is 1.0, which is the one we just created, and just say you want to build DLC, and the name of the DLC is just the name of the plugin. So in this case, it's Chicken Blade. Again, if you're using command line or build graph, you just pass dash based on release version and dash DLC name. Once you've cooked those files, you should validate that they actually contain the content that you cooked. So Unreal ships with a tool called Unreal Pack. It's just in the Win64/binaries directory, and you can use that to validate the content of your pack file, your UCAS file, etc., to make sure it contains what you expect. So the top command, just use Unreal Pack.exe, IO store, -list, and the path to your UCAS file, and then -csv, and it will dump out all of the contents of that in the CSV file at that location. If you want to inspect the pack file to look at the loosely packaged files, you just run Unreal Pack.exe, pass the pack file to it, and pass -list at the end. Just note that Unreal Pack is actually what Unreal uses to create the pack files as well. If you omit that -list at the end of the second command, it will just create an empty pack file at that path. I've made that mistake way too many times, and it just completely stumps your pack file. So don't worry too much about like the specifics of what this is. This just kind of shows the output that it actually produces. So you can see we've got the CSV. It shows the order of everything inside the container, the chunk ID, the package IDs, the paths to everything. We've got some shader archives. We've got the normal map down there. We've got some shader code, the header. It's just basically listing to validate that everything you had inside that, that plugin has been packaged. The output from listing just the pack file is a bit simpler. You can see there it's just listing the asset registry.bin file at the root of that pack file. So now we have the pack file that's been cooked. We've validated the contents in there. It's the content we expect. We actually need to now load that pack file. So to do this, we need to set up some core delegates in the engine. We need to discover and add plugins from the location that we've downloaded and installed our mods to. For each plugin that we've discovered inside that path, we want to mount and register it, mount that plugin's pack files, and then load the asset registry, shader library, and any other assets that you care about, such as that UGC metadata asset I mentioned before. And then your content will be ready to use. So what does this look like in practice? Now, this is a very code-heavy section. Again, don't worry too much about taking photos or anything like that, because the GitHub repository at the end will contain all of this. So this is basically inside what we're calling a UGC subsystem. It's just an engine subsystem. When the subsystem initializes, we want to add a delegate that hooks up to fcore delegates get on pack file mounted to. This delegate is called whenever the engine loads a pack file. The code we've got here, that fpack file contents iterator, just iterates through the pack file and just like logs out the contents of it with some verbose logging, just so you can validate and see what's actually being loaded after that pack file has been mounted. The second thing is that everything we're doing relies on the asset manager existing. We're using the asset manager to look up content from the loaded plugin. We're using primary data assets to be able to look that content up for our game. So we want to make sure that the asset manager is available when we're actually going to be refreshing our UGC. So we wait for the asset manager to be ready by waiting for this call or register on asset manager created delegate and passing our refresh UGC method. So after the asset manager is created, then we go ahead and refresh our UGC. So now let's start building out our refresh UGC method. This refresh UGC is actually the method in the GitHub repository I'll provide. So feel free to go there and just Control F for refresh UGC, and you can see all this. So we start by iterating through the mods, the mod installation path, which is that path parameter there, and we want to find all U plugin files. So we're just doing an fplatform file manager, get platform file, find files recursively for anything ending in .u plugin. For all those that we find, we want to try adding it to the plugins list in iPlugin Manager, add to plugins list. If it successfully adds them, then we want to make sure that we add that as a search path to the plugin manager, because the next time we refresh the plugins list, it will load all the plugins that it's found in those search paths that have been added. After that, we want to mount the plugins. So we're going to iterate through all the plugins that have been discovered after refresh by using iPlugin Manager get discovered plugins. Important to note that when you add plugins in this method, they start being disabled by default. So we always want to look to make sure plugins aren't enabled. And this is where that category from earlier on in the plugin JSON comes into play, where we're making sure that we're looking for a plugin descriptor category that's equal to UGC, and that it's a plugin that we're loading from our project. Project in this sense doesn't mean in the project directory, it just basically means non-engine, because this mod installation path might be C drive/temp or C drive/mods, and your game might be on D drive/mygame or something like that. Then we just want to mount the plugin with the plugin manager. We want to set up our mount paths using fpackage name register mount point. So those two paths that we get are the root path, which would just be /your plugin name, in this case /chickenblade, and then /chickenblade/content. and this is basically going to be the virtual file paths that Unreal's file system will use for all the content. This one is a little bit esoteric. This is not 100% necessary, so I'm not going to really dig into it too much. But it's important to note that if you're just using the engine, there is no way to load a pack file inside the editor. There is no F-platform pack file that's available inside the editor by default. So we set up this scope platform pack to basically allow iteration inside the editor for loading content from a pack file for your own testing purposes. I'm not going to go through the specifics of this. Just be aware that this exists inside that sample code. And it is necessary to be able to load those pack files inside the editor. So from here, all this functionality is going to be wrapped inside an FUGC package. This is basically our abstraction over a plugin to be able to manage everything relevant to one plugin as a piece of UGC that's been loaded. So we basically, from that previous refresh UGC method, we just create a new FUGC package, pass in the plugin reference, and from here we're doing all of that there. So we're setting up that scope platform pack override. We're just setting up some content paths and package paths from the plugin. Then we want to iterate through that search path to find just pack files. The fpack file search visitor will just look for only pack files inside of that directory. It won't look for UCAS, won't look for UTOC or anything else. Because when we load the pack file with IOStore, it will automatically load the CAS and the UTOC for us. We grab the mount point and then we just call platform pack file mount with the path to the pack file, the name of the mount point. Once that call is successful, recall that we set up that earlier delegate for when a pack file gets mounted. That will get called and we'll get some log output if we've got verbose logging turned on. Finally, we want to be able to load the asset registry, the shader cache, and any other specific assets we care about. So in this case, the asset registry, we just look for the asset registry.pin file. We call fassetRegistry load from disk, which will load the asset registry and then append it. When your game runs, you only have one instance of the asset registry that you actually look up data from. So any additional pack file with asset registries you need to load, you have to append that state to the base game one. If you've got shared shader material code, shared material shader code turned on, we just check that property, make sure that you're actually rendering, so you're not a server, you're actually rendering, the plugin's enabled, etc. And we use fshader code library, open plugin shader library to open that shader code and append it to the game's shader code state. And then finally, we're loading these specific assets that we're talking about, and this is kind of the last piece of magic to basically make our content discoverable for use. We're starting with that Chicken Blade UGC metadata. That call to load metadata just uses the asset manager to make an async load of that content. We store that in package metadata. And then we use the metadata to scan primary asset types. So if you're familiar with the asset registry and the asset manager, well, if you're not familiar, there's heaps of great talks already about those for how you can structure your content to utilize those types. So in this case, our Chicken Blade, we're just going to set the primary asset types to scan to say it's a weapon because we have a weapon data asset in there. And then we're just going to basically scan that. And then we're going to update our asset manager to invalidate scan paths and refresh the directory and make sure that this one's included. I'm not going to go through unloading because unloading is literally the reverse of all of these things. You would call, you would remove the scan, the asset scan path. You would, remove the handle to the package metadata. You would call unload shader code library. You would call unmount plugin, remove search path. So all of those have basically an alternate method to remove them, with the exception of the asset registry. That's handled for you automatically as long as nothing has an asset open. You can unmount a pack file and its asset registry will be automatically unloaded for you. So now your pack files are loaded. We need to validate and verify that they've been correctly loaded. Unreal does have some helper console commands here. There's 3 that I think are really useful. The first one is package name.dump mount points. It'll just give you a long list of all the mount points and where they're pointing. So in there, you'll see Chicken Blade somewhere in that list. Asset manager.dump type summary will dump all of the asset types and the paths that they're loaded from. So that scan and refresh path earlier, you can see there we've got the weapon, and the weapon has got 8 items that have been loaded from paths, game, items, weapon. And I've also got Chicken Blade there, and I've got the Hellhammer, which is another mod that I had when I was testing this out. And then finally, you can use asset registry get by path /Chicken Blade or whatever your mod is, and that will provide a full summary of all the assets that are available at that path. So you can see there it's logging out the details of that UGC metadata to validate all of that. So that was a lot. That's the most code-heavy section of this presentation. But once you've done all that, you should have a mod ready to use in-game. In this case, we have our Chicken Blade. We have our hell hammer, and they're in this menu that are being populated by looking up primary data assets. So, how can you actually use the content that you've now loaded from a pack file, made available in your asset registry or asset manager, etc.? Well, I think there are a few really interesting patterns that you can use. Number one is just to be data-driven. Follow really good asset referencing structure, good asset hygiene. Don't have hard references to things. Use the asset manager, use the asset registry to look up content, and just generally follow all those structure and guidance that Epic provides for how you reference assets. The second one, if you're familiar with Unreal Tournament, a little bit old school, mutators, which are basically a way to provide some hooks. I see you. Basically a way to provide some hooks to be able to respond to gameplay events. They actually are still a really good pattern. We've seen this in Insurgency and a couple of other games that are shipped with Mod.io as well. Just because it provides, blueprints really powerful, and content creators can create blueprints that inherit from a mutator, listen to events, and just do whatever they want, really. It's pretty flexible if you give the power of blueprint to them. And Lua scripting, this one's a bit more exploratory, but I think it's sort of worth touching on just scripting languages in general. We do see some games that do ship with their own custom sort of scripting or configuration languages, which I think are useful to think about. Lua is like a pretty simple one to understand, and I've also picked it as an example because it's what UE4SS uses as a scripting language. So just to sort of expand on these a little bit more, as I said, populate your menus, your assets, your loadouts, whatever your game uses. Use the asset manager and asset registry. I think every single game, UE4 game that's shipped on Mod.io, has been data-driven in some capacity, whether it's via looking things up from the asset registry or using the asset manager. So in this case, this is an example of the kind of thing that we might have done in Homeworld 3, where Homeworld 3, their first type that they shipped from mods was just maps, and they build their maps list literally just by looking for map primary asset types, and then just making sure that it's valid and adding that to a map list. Mutators, again, you want to go sort of a level lower and use the asset registry. You can basically look up a class that implements a URPG mutator as a blueprint. We're going to pretty much, get all the assets that match that filter from the asset registry. We're going to iterate over them, load the blueprints, validate they're valid, and then add them to a results list. And that can form, say, a list of mutators or a list of weapons or something like that. If you're going with mutators specifically, again, just set up a base blueprintable type for your mutator. Use a subsystem to basically query all the classes using the asset registry like that. Load them, make the mutators available, show them in your user interface or something like that. And then you can just dispatch events to them via your subsystem. So some common events are when a player spawns, when a player dies, when a player takes damage, those kinds of things. There's a lot you can do with just a handful of events to be able to sort of drive that kind of modability through mutators. If you were at Alyssa's talk earlier on today, they've done a similar thing with message buses. So you can think about, from her talk when they were dispatching message bus events for, when their events happen in gameplay, being able to let blueprints kind of catch those in a mutator structure and modify the gameplay is a nice way to go about it. Or you could use Lyra's gameplay messaging system. The main thing there to note is that if you use like a message bus or event-driven system like that, there's no guaranteed order for when they're going to be processed, and mutators in the Unreal Tournament structures traditionally kind of go up and down the stack, so the events kind of pass through. You can order mutators in specific order of behavior. You might not care about that for your game though, so it's sort of up to you, but that's the general structure that you can follow. So this one, Lua scripting, again, this is just an example of some further ways you could kind of hook into the engine's behavior to be able to provide some modability. This is not going to be part of the example code at the end, because it's kind of some exploratory stuff we're doing right now. The actual code I'm not going to provide it's not really super useful, just sort of shows some general patterns. But there are plenty of really good scripting plugins. You've got AngelScript. It's a fork of the engine that basically natively integrates a scripting language. You've got plugins like Lua Unreal. It's a Tencent one. They've used that in some commercial games. You've got a few others that exist. You can load Lua files alongside your pack files. So whenever you bundle up your mods, just basically ship those Lua files and look them up at load time as part of the FUGC package and append them to a state. You would need some specific security to sandbox the Lua runtime, particularly on consoles. But the example here is kind of inspired by UE4SS, where what we're doing is we're registering a hook that will intercept the call to engine.playercontroller.server-acknowledge-possession. That native method is just a U function. Its parameter is a controller. And then most of these things like Lua Unreal and the other Lua plugins provide a whole bunch of bindings that you can use. So in this case, we're just calling K2 get pawn, which is the blueprint method to get the pawn from the controller, K2 get actor location to get the pawn's location, then printing those out. So the way these hooks work, this is a little bit of a cheeky approach, but it does work. We pretty much set up a register hook method inside of our Lua state. That's bound to the Lua register hook method here, which we have inside of our Lua modding subsystem. Don't worry about the specifics here. All of this basically is just showing how to set up a method that basically is callable from Lua. But the real magic of this is that we grab that U class and we grab that function, we look it up, we look up the class, we look up the function, and then what we do is we call function set native func, and then basically replace the native function that's bound to that U function to our own one, which is that hook native function. That hook native function will then execute all the Lua code, or it could execute any sort of script code or transformation that you want. And then we call the original function back through the original function pointer that we cached. Another interesting way that you could do that, something like that, to kind of listen to all those events, is that there is the GU object array, which is a global object that allows you to add some listeners for when objects are created or destroyed. Again, you listen to those and kind of call a Lua method in the exact same way, call another scripting, an angel script method or whatever. So there's plenty of flexibility if you want to go down the scripting route to be able to intercept calls, listen to when things are created or spawned, and kind of get all of that, all of that power. But obviously this does come with some limitations. The asset registry can only contain a single entry for an asset. So overriding this entry is basically how we get that pack patching sort of structure that the Just Hack It Together crew works. But when you're doing dynamic content management, so we're loading and unloading all of our content inside the game, you can't really easily override this path when you load it and then unload the pack file and then restore it in a non-destructive fashion. So that kind of asset, overriding modding is kind of challenging in this situation in terms of how you transfer the asset registry. So yeah, uninstallation or unload just becomes a pain point in this scenario. There are stacks of different ways that you could try and resolve this if you really do care about taking this approach. You could just update the asset registry yourself if you really want. You could use runtime core redirects, which is something that we trialed. It does work for some things, it doesn't work for other things. Basically, the gist of core redirects is that it's a system that the engine has, is you want to redirect a reference of this asset or class or whatever to this one. That doesn't work for anything that has a CDO because the redirectors are resolved at CDO time, which basically happens when the engine starts up. So you can't redirect a character class to another character class because the engine would have already resolved that redirector when it launched. But you could do it for a texture in a map because if you want to change a stop sign to a give way sign, you could do that because that hadn't actually been loaded and that redirector hasn't actually been resolved yet. Again, you could redirect the spawn or create object methods in the same way that we use that add UObject global listener. Another approach that I've seen is to manually patch individual assets from the asset registry. So you could sort of provide a JSON patch sort of file with a bunch of values in there. You can load something from the asset registry, iterate across all of its F properties, and then set those values from the JSON file and store those values somewhere else. And then, again, you could store those inside your UGC package if that's kind of where that behavior is going to be happening. And then when that content gets unloaded, you could just revert all of that back onto the original reference. That might be a way to be able to say replace some references to different assets or something like that. But the general message is that additive content is the easiest way to go about doing this. It's what Unreal's designed to do. Everything for how pack files are loaded, even at startup, everything is designed to be additive. But that mutator style approach, if you want to get that replacement modding, mutators could work for that, right? If you want to replace a weapon skin, the way you could do that is wait for the player to spawn, listen to the player's spawn event, grab a reference to their character, grab a reference to their weapon, and then just call set material or something like that to be able to kind of get that similar effect. Yeah, and interrupting those or intercepting those engine calls, you could potentially do that from blueprints or some other scripting language as well. So some final thoughts. These are things that I could spend a long time talking about, but don't have a substantial amount of time to do it. If you're going to release a public editor for your game, you do need an agreement with Epic. So speak to your Epic rep if you do want to ship a custom editor. Ensure that you strip all of your source code out. Please do not ship your game's source code. You can do binary-only builds of the editor and of the engine that content creators can use. You can ship all of your assets and those sort of things. and make sure that you do ship out your releases for content creators to cook their content from. We just had Stalker 2 go live overnight with their mod kit. It is 700 gig, so they can get quite large, but they've basically provided all of their content, their scripting languages, all those sort of things for content creators to be able to create some pretty awesome stuff. Console tools are under NDA, so you cannot distribute those. So if you are interested in being able to do mods on consoles, you will need to use either some sort of cloud cooking service, we have one at Mod.io, or you might want to produce and prepare that content offline yourself. So we've got some studios who will basically manually curate that content. They will reach out to the content creators, say, we love your mod, we want it to go on console. They'll build that relationship, get the source files, cook them internally, and make them available to console players. Totally valid approach because most console holders do require some form of moderation system before content goes live. So you're going to have to go through reviewing that content anyway. They want safety on their platforms. The one thing I will mention with the console holders, though, is that they're way more receptive now to modding than what they were even like 3 or 4 years ago. The landscape for that's changed a fair bit, and we've seen that with the success of like Baldur's Gate 3, excitement for Witcher 3, a lot of those kind of limitations that console holders put on their platforms, and the hoops you had to jump through are kind of very slowly reducing as they're getting familiar with this whole concept of mods being on their consoles. Game feature plugins are cool. They don't really work well with this approach. There's no like magic combination of cooking parameters, settings or anything like that that can cook and dynamically load a game feature plugin at runtime in the same way we're loading pack files. You do need to basically like include them in your base game, just kind of make them toggleable, so it doesn't really work that well without making engine modifications. But the main theme is that everything I've talked about can be done with no changes to the engine, even like intercepting those U functions, listening to those object creations, all of the pack file loading, mutator structures, all that sort of stuff. You can do it inside a set of plugins. You can achieve a lot more if you want to go ahead and modify the engine, but I think you can get a long way with just a simple set of plugins, this kind of behavior that I'm talking about, and being able to build out a suite of tools that you can use for your own internal games, more than one game, and kind of continue to build on that tool set for yourself. This is the repository link. This is an open source plugin called Mod.io UGC that basically provides all the functionality I've talked about here. I do want to say a special thanks to these 3 people up here who all work at Mod.io as engineers. All of this work that we've done for being able to help studios doesn't come without the support of Mod.io and particularly the engineers that are part of my team. So massive thank you to them for being able to help. If you care about any of my rantings about cricket, thanks Chris, or mods or game development, feel free to follow me on Blue Sky. Or if you sort of want to have a bigger conversation about mod support in your game, feel free to email me. My address is not up there, but it's just matt@mod.io. Thank you. Any questions? Yo, let's do it.
Okay, can you hear me?
Yep, all good.
Seems like okay. So I've been also have roots from modding myself as well, and yep. I also want to intend to make my game project also moddable. Yep. So my first question is it required to have the U project file to be distributed, or maybe have a custom editor like that?
So it's not. So we kind of see a couple of different ways that studios go about this. So we got games like TalkDrift 2 and a few others who basically, they don't ship an entire editor with their U project file and their assets and those kind of things. What they do is they actually ship a plugin that can be used with a launcher version of the engine. That plugin will contain some basic sort of stubbed out types for some of the assets that are, some of the metadata assets that are required for their content to be loaded by their game. Obviously, the structure's got to match one-to-one for that, for it to work. And they include like some assets. TalkDrift 2 is a racing game. They include some assets to like build tracks from that. So they kind of provide their mod kit just as a plugin for the vanilla editor to be able to produce all that content. It still follows the same structure. You've got to produce a release if you want to be referencing any assets in any other way. But shipping that custom editor really depends on whether you want your base content to be referenceable and usable by content creators, or whether you want to not do that. Both approaches are valid depending on the kind of content that you want to make.
Okay, all right. So the second question is, when it comes to multi-platforms, like on PC, for example, like we have Windows and Linux platforms, yep. Is it possible to have one mod cooked for both of them, like at once, or do we need like modders to have cook the content for Windows Edge and then also Linux like that?
They'll need to cook the content for separate platforms, yeah. The upside is that Windows and Linux, you can both cook from a Windows box because there is a cross-compile toolkit for Linux. So when you launch the editor, if you have the cross-compile toolkit for Linux installed, you can target Linux for built-in cooks. You can't do that for a Mac or iOS. You have to actually do that from a Mac. And obviously Android you can do from Windows as well. So it's only the NDA platforms, PlayStation 4, 5, Xbox, Switch, basically, which you need to do in some more tightly controlled situation by your studio.
Yeah, okay. That's it for my question. Thank you.
Thank you.
Hi, so I'm Kai from Mbox Studios. Thank you so much for the very insightful talk into modding. I primarily have a question regarding unloading mods after you load it in. So from my understanding, I do know that the pack file loading sequence is done on game start instead of so my question is more like, primarily if we have a competitive online game where we still want to support mod support, how would you recommend approaching this issue where we would need, for example, to unload any mods when they join an official server? Because we wouldn't want, obviously, mods in official servers so that we can obviously give them rewards and stuff like that at the end.
Yep. So we have a lot of multiplayer games, like Insurgency is probably the best example of this. So they start up by having official servers, which are not modded, and they have modded servers, which provide a set of server mutators or something like that, and they show that inside the user interface. Generally, the way that I think you should go about that is that it really depends on your multiplayer model. If you're hosting official dedicated servers with some subset of mods enabled, in whatever system you're producing those mods, like Mod.io or a CDN or some other distribution system, take those mod IDs, put them into the lobby session data, so when any player joins, basically on that client join, you just say, hey, what mods you've already got loaded or installed, what mods are on the server, you might need to download them if they're server and client mods, or just disable and unload anything that's not in that list that's been provided as part of the lobby metadata. We do have some other customers we're working with who kind of go the opposite way, where they don't have dedicated servers that you join, but they have dedicated servers that get spun up on demand from a lobby. So I'm a player, I've invited 3 friends to play, I'm going to spin up a dedicated server for my own, my own party. And in that situation, the lobby leaders list is the one that becomes authoritative. So it'll be the opposite. We'll basically send that data to the server when it spins up, and the server will download and make those mods available and then sort of send those over either via lobby session data or just via standard multiplayer replication to the other players who need to know about it. So all that is kind of it really depends on your own multiplayer model, but generally advertising through lobby metadata is the way to go for that.
Right, thank you. And so loading and unloading pack file, the process of then unloading and loading mods is not that tricky. It's more straightforward than I imagine, I'm guessing. Yeah,
so if you're using this is why I think you shouldn't use the engines like loading behavior on startup, because that's kind of when things become complex for how you got to load and unload content, mainly. So if you load that content in dynamically, then the unload is literally the reverse of all that code that I had up there. So it's you can wrap all that content in a handful of methods and calling unload or disable or some sort of internal method that means that content is no longer part of the asset registry to be discoverable. That's pretty much the best way to go about it.
Right, thank you.
Cool, no worries.
Hi, I just have a question that's not mentioned in the presentation, but how about for mods, right, that requires for you to have certain mod load orders and also mod dependencies, you have a base mod that's other mods are dependent on. How would that be the case for Unreal Engine?
Yeah, so dependencies are a little bit of a challenging one in that sense, because we haven't seen many, if any, games that use Unreal Engine that are dependent on another mod, because you have 2 separate cooked pack files that basically won't sort of reference each other in any sort of way unless they're doing some really funky stuff, which you probably shouldn't allow people to do in terms of looking up content from another mod. But in terms of the load order, we have sort of seen all sorts of different approaches for this, and the general approach would just be you've got a list of mods that you have, and again, this is why load them dynamically rather than load them on startup, have them in your user interface, and just have an ordered list of all of those plugins that have been discovered, or all of those metadata for the mods that you've got discovered, list them in order that you want them to be loaded, and then just call that loading method one by one for each of those. So that you could either do that refresh UGC, scan the whole directory and do all the loading in one piece, or you could scan the directory, find all the mods that are available as plugins, list them in your user interface, or let them change the order in the user interface, and then basically call load on each of them in that order as opposed to just the order you've scanned them from the plugins directory. Does that make sense?
Regarding the mod dependency, like I'm more thinking about like just now you mentioned about like something like the mutator, like maybe like their community members just make like a base mutator, like add, for example, like a RTS game, you just add units, for example, and then other people can depend on that to just add units easily. Is that that kind of thing? Like I would kind of like make the load order or something that's loaded first, and then there'll be a new mutator class to load the rest. Would it kind of work like that?
Kind of, but then you're kind of like just getting more into like internally resolving the load order yourself. So like again, there's a bunch of different ways you can do it. If you like look on Steam Workshop, for instance, they basically have a dependencies list. You can go into the settings tab, go to Workshop, find the game you've got subscriptions for, and just hit like automatically find load order, and it will iterate through and find the best load order based on all the dependency information. So if you use a platform like Mod.io or some other platform that has dependencies, you can kind of calculate that dependency order yourself. And the tool like Mod.io going into the user interface, you can set up those dependencies on the mod itself inside whatever tool you're using. So that's kind of one way to be able to drive that from the content outside of the mod. The content inside of the mod, you're just going to be loading them all, like storing everything and then unloading them and reloading them. If you did that and relied on like the content of the mod itself, I would probably just have like a JSON file or some sort of metadata file that exists outside of the mod itself, and then scan and load those all, figure out the order, and then perform the loading after that. So it's more about separating that search and ordering from the actual loading process itself, and then you can kind of go about getting that order any way that you want.
Okay, thank you.
Cool.
Hey, thanks for the talk.
Thanks.
I was wondering, do you have any tips and tricks for if, say, you release new versions of your base game, how to make sure that you're not loading outdated mods, or to check if you're loading outdated mods, or where you would even do that in your game or externally?
Yeah, so you do that both ways, whether you do it in your game or externally, either one would work. Generally speaking, unless you make like major changes, like upgrade your version of the engine, change a whole bunch of assets or something like that, loosely, because they're based on the asset registry and that cooking is pretty sure it's pretty deterministic, most mods will still work unless you make drastic changes to the structure of the engine or game or something like that. Again, when we talk to customers from Mod.io, the way we recommend doing it, we've got a mod tagging system. So any major release where you know something's going to break, you can just go and tag all the old mods with, say, it's version 1.0 of the game, and then version 2.0 of the game, and then when you start up your game with that new version, just look for mods that have the 2.0 tag. So again, that metadata can exist on the platform that you're using outside of that, or you could, in the uplugin descriptor, provide a version number. I think that's how Fortnite works actually, is they provide a version number inside of the uplugin file. I think Lyra has a similar system as well for some of their game feature plugins where you have like a version number in there. So your uplugin files could have a version that match the version of your game that it's on, and then content creators via your CDN or some other tool that they do that, then you can go ahead and upgrade those uplugin fields and query them before you actually load. So kind of both, your game could look up some metadata or attempt to load and see if it errors, or you could have that metadata sitting outside the game and only show what's compatible, basically. Cool, awesome. All right, thanks everyone.